Hello, my name is nigelargriffiths. So we're at IBM Power Systems Europe looking at AX and Linux. You can see my Hotmail address there if you want to get in contact with me, and the project is on SourceForge, but the tiny URL /njmon will get you there. This is the 10th video in this series on njmon, and as you can see the title is nimon, which is very much like njmon. It's the same source code, but the data goes directly to InfluxDB. I'll explain that in the next couple of charts. So here's the previous version where we introduced a new in the middle project in here called njmond. The njmons send all the data over the network to this daemon process, and it logs into InfluxDB and uploads the data into the database for you. And this has been working very successfully for 6 months or so. As a side project, I thought let's try and make things simpler, and so we've changed now to version 60. Did you notice the 60 changing here? And everything is working the same, except if I change a compiler flag, I now create something called nimon. So let me show you how the architecture for this program works. Here it is. Whoa! We just deleted the thing in the middle. So here, the njmon processes, now called nimon, I for straight to Influx, now actually have worked out how to connect to the Influx database itself, and the output, instead of coming out in JSON, is now in Influx Line Protocol format. So I've swapped out the functions that created JSON for a new set of functions that create the Influx Line Protocol format. So apart from the I in the name, then we have a whole bunch of parameters in here, and let's highlight these. This was the name with njmon, the host name or IP address of the njmond.py process was running on. That was usually the same machine as the InfluxDB database was on, so it may actually stay with the same name in here. This port number isn't the port number for njmond. This is the standard port number that InfluxDB itself uses. That can be changed to the configuration of InfluxDB, but I guess that most people might have left it at the 8086. And nimon is logging in directly into InfluxDB and has to tell InfluxDB which database it wants the data to go in. So this is the -x factor in here. And for authentication, we need the username and password as well to get into the Influx database. The other difference, of course, is we're sending in here not JSON data, but this InfluxDB Line Protocol format. So there's a whole bunch of things in here that are actually gone missing. No JSON data format in here. There's no JSON files. You can't save a copy to a file to import into other Influx databases, for example, or other tools. If you like the JSON data because you're using that with Elastic, also called Elasticsearch or ELK, or Splunk, or just taking it into some Python code, well, you can't do that with nimon. So the installation gets even simpler. Now we install InfluxDB Grafana. You go to the InfluxDB and run the influx command, and you create a database there called njmon. Exit that. Then for each of the endpoints, you install the nimon binary program and add a cron tam. If you want to do it on a daily basis, the command will do quite nicely. If you want to do it on an hourly basis, you can use the -k option, and it will just let it run. If it's still running, if it finds that the nimon has stopped, then it'll actually restart it on an hourly basis for you. If you're using njmon 50 and want to go to 60, well, there's a few little bugs, probably worth having the fixes for those, but it's not a big thing. You'll just update your njmon and nothing changes apart from that. If you want to move now to nimon instead, then you'll introduce the new nimon binary. You'll have to change the -p option to point to the influx port, and then you have to add those extra XYZ options to your command line. But that's done. And you can coexist. You can go to each of your endpoints in turn, perform these operations, and then it'll be sitting over here instead, and slowly convert all of these to nimon, and then you won't be using your njmond. Let's have a quick look at this InfluxDB Line Protocol 101. You can go and look at the documentation there at the influxdata.com website. All you really need to know is that we have in each line, after we've connected to InfluxDB and told it our credentials and which database we want to add data to, we just send it lots of these lines one after the other. So the CPU here is known as the measurement. This is the statistic name, so CPU, memory, disks, adapters, and whatever you got in your computer. Then we have the stats here that I put into purple, so it's the name of the stat, equals, and the value. The values can be floating point numbers, as we have here. They can be integers. You're meant to put a little I at the end of the number, or it can be a string in double quotes. And this great big part number thing at the end in here is the timestamp. It's the epoch nanoseconds or something like that. This is the time since the 1st of January 1970. A lot of Unix computers are still using those sorts of numbers. Here's a slightly more complicated example. We've added in here as a comma, and then these are known as tags. So if you want to go into your database and say, I just want to look at one particular virtual machine with a host name of Silver 5, then this is the tag that allows the Influx database to say, okay, here's the data that just about that particular server. This OS tag is for a completely different reason. In Grafana, you may have a graph that will work with AIX data but not Linux. So you can ask for a list of all the virtual machines that are running AIX that will work with this graph and eliminate the machines that won't work with this particular graph. Now here's actually a real one, slightly more complicated. There's all sorts of CPUs, and then there's the physical and logical CPUs, and then they have the individual CPU cores underneath that. We also have some other things in here. Architecture, I should have spelt that with less letters in here perhaps, but this is a Power 9 server or a Power 8 server. It could be an AMD 64 server. I actually like the serial numbers in here because then we can detect the virtual machines on a particular machine, because those can move over time, so they will be automatically regrouped. And this thing in here is a little bit of an IBM-ism. This is a machine type model. This IBM gobbledygook means it's a Power 9 S924 model. But this allows me on one graph to just look at my servers of a particular type. You'll notice in here there's no great big timestamp. If you send this input into InfluxDB, it will generate the right time of when this data arrived at the InfluxDB machine. This saves a lot of mucking about with time zones and clock drift on our particular servers. They'll all be very consistent. That's all you really need to know about Line Protocol. Now you can use nmon and put a -f in here, and it will generate a file full of the Line Protocol. Of course, you can't then go and take that and push it into the InfluxDB because the timestamps would actually be wrong. You'll get the timestamps of when you loaded it as opposed to when you created the file. Here's a little bit of advanced stuff. You don't really need to know this, but we can use this line protocol directly with InfluxDB. So on the InfluxDB server, this is the command line for Influx, and so it gives us a prompt. We can do various things in here, like the create database njmon. If we wanted to then actually do operations with that particular database, then we say use the database name. We can do show databases if you've forgotten what the databases are called. Then we've sort of got this database open. If we do an insert statement, this is a little bit like SQL, but in here is actually a line protocol. I put a note in here, don't forget this space. It's very difficult to sometimes spot the space in a long complex line. We can with nimon worry that we started it up and it seems to be running okay, but is the data actually getting to the database? Well, again, there's another select SQL type statement in here. The measurement is now a table name inside the database, and the various values in here, if you like, are the columns of the table. If we do a select star from the table, it will actually output, in this case, 2.6 million records. Don't really want those zooming up the screen, but in SQL terms you have like a count of any row, and it will just give us the numbers of rows with these values in it. And so we can see this, and if it's a brand new database, we can see it going from 1 to 2 to 3 to 4 as nimon captures the data and sends it back to the database. It gives you a good comfort factor about the data is actually arriving. So a little bit more information about how we got two projects or one project here. Well, we have one source code file for both of them. Simple compile time option of -D option for njmon and nimon, and we get the two different flavors of the program. All the stats collection code is exactly the same. I didn't want to duplicate any of that, but the output function that generates JSON or the line protocol, we have two sets of those, and they get one or other gets compiled in depending on what you want. About 200 lines of the code. How big is actually the njmon and nimon code? Is about 5,000 lines for AX and 4,000 lines for Linux, but the AX code generates a lot more stats. We're using the perfstat library to get that stats. With Linux, a lot more code is involved in getting the stats, and there's less stats available anyway. Now, those number of stats greatly depends on the size of your virtual machine or your server. If you have lots of CPUs, disks, networks, file systems, then these numbers grow. Perhaps disks have 20 stats, so for 1,000 disks you have 20,000 stats per snapshot, so be careful on big machines. If you're also collecting the process stats, well, there's a lot of those, but you can have thousands of processes running, so again the stats can get very large per snapshot. So what are the big improvements for version 60 and above? Well, the big line item is nmon. We've talked about that already. A couple of tiny little bugs have been found and killed. And one of the bigger ones is that we fixed this not a number problem. It's also known as a NaN issue. For example, if you divide by 0, the result is it 0, or is it 1, or is it infinite? Well, we don't know. It's not defined. So there's a special number that is defined as not a number, which means you should never print out this number because it's invalid. But of course, if we print out not a number and try and put that as a string into a double floating point number into the Influx database, it says no, you can't put a string into a floating point number. So what we now do is we capture when the number is invalid, and we don't forward those stats to InfluxDB. InfluxDB and Grafana are very happy to have data missing if you don't know what it is at that time, and we can actually point those out in the graph as well. And we come to the end of our movie number 10 in this series, nmon. It's been great fun developing this new feature. Certainly make things simpler on the system's administration side, but I do want to note that the njmon, the JSON data, the JSON files, they're not going away because they're still a key feature and benefit. And don't forget to give us a thumbs up if you enjoyed this and learned something. Don't forget to subscribe. Thank you for your time.